In this video, I want to define distance. So I start with 2 points in time. I have some initial time and some final time. And given these 2 points in time, I can identify the two specific position function vectors at those 2 points in time. The position function vector at t initial, and I might give that a shorthand name, it might r sub I, as well as the position vector at t final, and I might call that r sub f, but these are two vectors that are given by the position vector function at these two times. Okay, let's look at what those may be. So if I have, let's say, a coordinate system, and at t initial I have my vector points there, and then at t final I have a position vector that points there. And let's say that the particle traveled in a straight line between these 2 points. And that line is 12 meters long. Then the distance that the particle traveled going between those 2 points is 12 meters. And so the distance is simply the total length traveled going between 2 points identified by the two position vectors r initial and r final. So, for example, if the particle did not go in a straight line as shown, but if the particle went, say, down this way 8 meters, and then straight over 12 meters, and then up 8 meters. In this case, the distance is 28 meters. 8 plus 12 is 20, plus another 8, 28 meters. Even though they left from the same point, the distance traveled is different, and so the distance is different. Okay, and so if we can compare this to displacement, in both cases, the displacement was the same. The displacement, which is a vector, it has a magnitude 12 meters, and it points in the positive x direction. I didn't really label my axes here. Plus x plus y. My displacement vector looks like that blue vector. It has a magnitude of 12 meters, and it points along the positive x-axis. It's a vector. But my distance, which is not a vector, is a scalar, is the total length traveled, and in the first case was 12 meters, in the second case 28. So let's do a different, let's look at a different plus x plus y system, and in this case we're going to say that our initial vector is equal to the final vector, and the path traveled by the particle went down 10 meters, then went over 5 meters, then went up 10 meters, and then over 5 meters. So in this case, the distance traveled, which is the total length, was 30 meters. 10 plus 5 is 15, plus 10, 25, plus 5 is 30. The displacement, which is the vector difference between the final and initial vector, equals. They are equal. But minus this is equal to 0. Because they're equal to each other, when you subtract them, you get the 0 vector. So in this case, displacement 0, even though there was a positive distance.